All right, guys, welcome to an HVAC know-it-all training video. Today we're going to talk about the hot gas bypass valve, HGBV for short. If you're looking at a legend on a wiring diagram or some literature and you see these four letters, it's probably talking about a hot gas bypass valve, which I've drawn right here. So let's get into this. So what I've done for you guys is draw out the refrigeration cycle, the compressor, the condenser, the metering device. Could be a TX valve, cap tube, could be a fixed orifice. We have the evaporator here as well. Now, teed off the discharge line, we have true discharge line moving across from the discharge line to the inlet of the evaporator. Now, in between that, we have a solenoid valve with a question mark because some manufacturers don't put them there. Depending who's installing it, it might not be there as well. But just know that sometimes they're there and they're on or off, flow or no flow. So when the system's running, this will be energized, opened up, providing flow to your hot gas bypass valve. This can be mechanical, this can be electronic. I've drawn a mechanical device because I'm used to seeing these in the field quite a bit. So we have discharge gas in, discharge gas out, and we have an equalization line coming down to the suction line right here after the evaporator, and we enter between the metering device and before the evaporator inlet. Sometimes it can be piped down into the suction line, but usually this is where you see it to provide a false load on the evaporator. Now, what is the job of the hot gas bypass valve? It provides false loading on the evaporator. Basically, it raises the temperature of the evaporator in low load conditions. Now, low ambient and low load are two different things. Low ambient is when we're dealing with cold outside temperatures. Low load is when we're dealing with temperatures in a room that are lower than normal. A lot of techs get that confused, and we need to determine the difference between low ambient and low load so we can tell what this piece of equipment does within a system. So let me give you an example of an application where a hot gas bypass valve would be used. Let's take a theater, for example. A theater, you have a couple of hundred seats, you have people ushering in. What happens when they usher in? The temperature of that theater rises because we have a lot of body heat in there. It rises, the AC kicks on. We're going to provide an evaporator temperature of about 40 degrees saturated suction temperature, or a 40-degree evaporator. That's kind of rule of thumb, normal AC sort of evaporator temperature. Now, I'm focusing on temperature because 410A, R22, 407C, drop-ins all might have a different pressure. But the evaporator temperature is going to stay pretty much the same, okay? This is normal. This is running at full capacity when that theater has a bunch of people in it. Now, at intermission, when people leave, they go out for a smoke, make a call, have a drink, whatever. People leave, the load drops off because that body heat is now removed from the theater. When the load drops off, our evaporator temperature is also going to drop off. We might cycle the machine off. Cycling the machine off is not that, it's fine, but what can happen is we cycle it off and it comes back on. Cycle it off, it comes back on, and it short cycles. Okay, and then it has to ramp up again and get going. So what we do is create a false load in the evaporator to keep that machine running and prevent it from cycling off and short cycling. So the way that we do this, very, very simple way we do this. So we have hot gas through an open solenoid valve into this mechanical device. Now, if you take the cap off of this, and this is just one particular valve, so you take the cap off, inside you have access to a threaded portion that you can screw in and out, basically put tension on or back tension off. Now, in the middle of that is an Allen key opening where you can put an Allen screw or an Allen key inside and adjust it. So what we want to do is we want to run the system in a low load condition, all right, with nobody in that theater. When it's running in a low load condition, when we hit the minimum evaporator temperature that we want to maintain, now I've written 32 degrees here because we don't really want to drop below that. We could start to freeze, even though we do have some superheat added into that, and our suction line is probably warmer than this. But for a rule of thumb, let's not drop below this. So we would run the machine, right, under a low load condition. We would allow the evaporator temperature to drop off, and once we've seen where we kind of wanted it to be, we would start adjusting the spring tension on that. And as we adjust it, we're going to add hot gas into here. As we add hot gas into here, that's going to raise the temperature of the evaporator up. So as we raise the evap temperature up, it's warmer. The discharge air coming out of the machine is now warmer. Less chance that machine is going to cycle off. It's going to continue to run flat, stay running. When all the people usher back in from outside, when they're having their smoke break or on the phone, we are going to go back to normal conditions because that body heat is going to raise the temperature of that theater. All right, this evaporator will raise naturally on its own. This will start to back off hot gas. So we're no longer in a low load condition. We're running normally. This will back off hot gas and we're running back to normal at full capacity. When everybody leaves again, the load drops off because the body heat is gone. We're going to start to drop the evaporator temperature, but we set this for 32, for example. If we hit 31, somewhere in that range, this is going to start feeding hot gas to maintain that minimum evaporator temperature that we've set from this device. So that, in a nutshell, generally is how a hot gas bypass valve works, and that is an example of an application it works really well in. Happy HVACing, guys.